This is 2026 physics question paper of CBSE class 12th that conducted on 20th February. Question number 1, section A. Phase difference between the two superimposing waves that gives to a bright spot in Young's double slit experiment, where n is an integer. So we know that the maximum intensity we can find when phase difference between the two waves is 0, 2 pi, 4 pi, that is 2 n pi, where n equal to 0, 1, 2, 3. It means this is question 1 का E सही है. If R1 R2 are the radii of the atomic nuclei of mass 64 and 27 respectively, then R1 upon R2, we know that R equal to R naught a power 1 by 3, then R1 upon R2 is equal to A1 upon A2 power 1 by 3. A1 is 64 and A2 is 27. Power 1 by 3 means that is 4 by 3. That is, this is right. An equiconvex lens of focal length 15 cm is cut into two equal plano-convex halves. The focal length of each will be 1 upon f equal to n minus 1, 1 upon r1 minus 1 upon r2. There are two lengths by cutting in which one surface becomes plane. Then we see that 1 upon f dash is n minus 1 after cutting 1 upon r minus 1 upon infinity, because plane surface have radius of curvature infinity. It means this 1 upon f is equal to n minus 1, since radius of curvature of both is same. For convex, this is minus n minus 1 2 by r 1 upon f, and 1 upon f dash is n minus 1 1 upon r. What is the relation between f and f dash? Now 1 upon f divided by 1 upon f dash, we get 1 upon r divided by 2 upon r divided by 1 upon r. F dash upon f is equal to 2 by 1, that is f dash equal to 2 times of f, that is becomes double. This is answer. Next, a plano-convex lens made of glass has a curved surface whose radius is 40 cm. The image form of an object is of the same size as that of the object. The distance of the object from the lens. So first of all, we will find the focal length. 1.5 minus 1 upon f equal to n minus 1 upon 2 upon r, since there is convex lens of equal radius of curvature. Plano-convex 1 upon r minus 1 upon infinity. तो F इक्वल टू R upon n minus 1, that is 40 divided by 1.5 minus 1, that is 40 upon 0.5, that is 80 centimeter. F equal to 80 centimeter. And we know that for a lens, same size of object is same size of the image is formed when object is placed at 2f distance, that is u equal to 2f, that is 2 into 80 equal to 160 centimeter. This will be answer. Next, radiation of wavelength 200 nanometer is incident on the photosensitive surface of Hubble function. Kinetic energy of the fastest electron emitted from this surface. First of all, change this 200 nanometer wavelength into energy. We know that E equal to hc by lambda, and in electron volt we divide 1.6 into 10 power minus 9. Finally, this is 6 point Planck constant, 6.02 10 power minus 34 into 3 into 10 power 8 divided by wavelength 200 10 power minus 19 1.6 into 10 power minus 19. ये अप्रॉक्सीमेटली 4 आएगा, तो इसको कर देते हैं 12 डिवाइडेड बाई 2, 10 पावर 8 और ये माइनस 34, 10 पावर 26 और ये 10 पावर माइनस 19 और 10 पावर माइनस 9, 10 पावर 28 माइनस हो गया, ये ऊपर जाएगा 10 पावर minus 26 or plus 28, that is we get, and this is 200 10 पावर 26 हो जाएगा, तो ये तो कट जाएगा, 6 इलेक्ट्रॉन वोल्ट अप्रॉक्सीमेटली फोटोन की एनर्जी आ गई. एंड वी नो दैट हाफ mv max square equal to h nu minus h nu naught. And what is the energy? This h nu, that is c by lambda, is 6 electron volt minus 4.2 electron volt. ये 1.8 इलेक्ट्रॉन वोल्ट के आसपास आ रहा है, तो ये हो जाएगा. प्लांक कांस्टेंट की वैल्यू शायद गलत रखें, थोड़ा सा ज़्यादा है, 6.64 होता है. नेक्स्ट, a metallic rod of 1 meter length is rotated with frequency 40 revolution per second, मीन्स ये फ्रीक्वेंसी f दिया है. with one end hinged at the center and other end is on the circumference of a circular metallic ring of 1 meter, length दिया है L 1 meter, passing through center and perpendicular to the plane of ring. A constant and uniform magnetic field length parallel to the axis is present in the region. The value of EMF induced in the center and the metallic ring is, इसका फार्मूला होता है 1/2 BLV. We can change this V इक्वल टू R इंटू ओमेगा हो जाएगा, तो BL स्क्वायर इंटू ओमेगा, हाफ B की वैल्यू 0.5, 1 का स्क्वायर ओमेगा 2 पाई N that is 40. तो ये तो हो जाएगा 2 और ये मिलके इससे कट जाएगा, नहीं 1 हो जाएगा ये, और ये 2 इससे मिलके 20 हो जाएगा, और ये हो जाएगा 20 पाई 20 इंटू 3.14, that is 63K approximate, 63 volt. Next, which of the following p-n junction diode is forward bias? Forward bias means p side, this is n side, p side will be more positive, but here is plus 5, this is plus 10 volt, it means this is reverse bias, this is negative, this is positive. Next, 0 and 0 is less than 1 volt, it means this is negative, this is positive. Minus 1.5 volt and minus 1 volt and minus 1.5, this is positive, this is negative, so this is forward bias. 0, this is negative, this is positive, here reverse bias, it means answer is this. When a forward bias voltage in a semiconductor is changed from a forward current flows with narrator, the forward bias resistance of the circuit will be, when the forward bias voltage in semiconductor is changed from 0.8 to 1 volt, the forward current changes from the diode resistance R equal to dV upon V equal to I into R, then dV upon di. Change in voltage is 0.2 as 1 minus 0.8 upon 2 into 10 power minus 3. 2 into 10 power minus 3. This is 0.2 into 10 power 3 upon 2. This is 2 upon 2 into 10 power 2. That is 100. Yeah. A plane electromagnetic wave through a medium magnetic field associated with V equal to, what is given? First write omega t. Omega is given 3 into 10 power 8 and k is equal to 150. Now V equal to omega by k. Omega is equal to 3 into 10 power 8 divided by 150. This is 2 into 10 power 8 meter per second. This answers. The velocity of photoelectrons emitted from a surface depends on the wavelength of the incident radiation only, intensity of incident radiation only, work function of the functions only, no, both wavelength of the incident and work functions, as half mv square equal to h nu minus h nu naught. This is property of the work function and this is frequency of the incident radiation. Frequency is associated with wavelength and this is work function, so that both dependencies. Thin plano convex lens and a thin equiconvex lens are kept in contact as shown in the figure. Assuming both the lenses are made of glass of 20 and r of radius aperture. Focal length of the combination. Actually, this is combination of a convex lens, plano-convex lens, and this is concave lens. Both have same radius of curvature. Now first find the focal length of convex lens. 1 upon f equal to mu minus 1 r by 1 by r हो जाएगा, because one surface is plane, then this is infinity. Suppose that this is f1, concave का हो जाएगा mu minus 1 1 upon r1, this is negative, minus this is positive. Finally, this is mu minus 1 2 upon r, this is minus. And we know that for lens combination 1 upon f equal to 1 upon f1 plus f2. So we can add this and we get mu minus 1 minus 2 mu minus 1 and common of both 1 by r. This is minus mu minus 1 upon r, this is 1 upon f. Now f equal to minus r upon mu minus 1. This is answer B. Okay, from question number 1 to 12 is MCQ. This is completed here.